part 2 of the chemistry chapter. So I want to touch on water a little bit. Water is the most important liquid that we have on Earth. Some consider it the universal solvent. So that means things dissolve in water. It doesn't dissolve everything, so that's why some other people say, nah, it's not the universal solvent. Maybe there's something out there we'll find that can dissolve everything. So it is a solvent. So the difference between a solvent and a solute would be something like salt or your Kool-Aid, right? You put that in your water, so that's the solute that you're putting in the solvent, and then it comes apart, right? It disassociates. Like I showed you that one video, that tiny short video that you should watch about the dissociation of salt in water. So, so universal solvent. So water has properties that are very unique and very important. For one thing, we'll get into the solid liquid gas because my solid is melting out here. It's hot out here, and I've done a couple takes already on this video. So you have liquid water, of course, right? Liquid water. And you have, well, it's kind of like melting, but solid, and that's your ice. And then water vapor, that's your gas, your gaseous state of water. So something unique though is when you have the solid, right, the solid, rather than sinking, right, it floats. So that's a solid floating on a liquid. That's pretty unique. So what that is, and let me show you if you're not looking at your book, and this is addition 2, but see those molecules there? Those are water molecules, and when you have a solid, rather than those molecules scrunching together, they actually, remember the hydrogen bonds I talked about? The hydrogen bonds actually act to separate out those water molecules. So that's the bond. Remember, the oxygen and the hydrogen in water are bound together by a covalent bond. They're sharing electrons. But if you have one, water molecule next to another one, they come together because they're slightly drawn toward one another. And that was in our other page. This was in the last PowerPoint, but you might not have seen it or the last video. So there's a little tiny charge, right? So the hydrogen has a little bit of a positive charge. The oxygen has a little bit of a negative charge because the electrons are being pulled a little bit closer to that oxygen molecule because it has more protons, so it's going to pull more of the electrons over that direction. So you have those little charges, so that's why one water molecule is attracted to another water molecule, and they stay together by that hydrogen bonds. So in ice, when it freezes, those hydrogen bonds, they like straighten out, right? They kind of come apart so that it's like a lattice, like the ice. Oh my gosh, my ice is almost melted here. So it actually makes it less dense, and then it can float on water. Super important. Thank goodness that happens, because if ice, like if ponds froze from the bottom up, or the ice sunk or whatever, you wouldn't have that protection in the wintertime over lakes and ponds. You freeze over, and then it's warm enough underneath for everything to kind of live and wait out the winter, hibernate maybe, until it warms up again, right? So that's important. Water, another reason that it takes so long for water to heat up, and you're like waiting for your water to boil so you can make your mac and cheese, or have your tea, That's my English accent. It takes a long time for the water to boil, and that's because of those hydrogen bonds. So it's the heat beginning to break those bonds, those hydrogen bonds of the water. So you have that, and then it takes a long time to heat up, and it takes a long time to cool down water as well. So that's some good stuff too. So because like we're mostly made up of water, right? We have a lot of water in us. If water froze or boiled really fast, we'd freeze and boil really fast, and we would be dead. So it's a good thing that it takes a while for that to happen. And it's also a good thing, I'm trying to think the other point I was going to make. I'll think of it later. Okay, so there's a couple things. So that is the structure with the hydrogen bonds and how that makes it unique with solid liquid gas. Another thing would be adhesion and cohesion. So cohesion is when one water molecule is attracted to another water molecule. Now, when I do these drops of water, they're bigger than an actual water molecule. We can't see the, just the hydrogen, oxygen, tiny little atoms. But, so these are several molecules already together. But as you can see, this maybe happens on your car after it rains, right? The beads kind of like find each other and they it's kind of like a game now. They cohesively get together. There we go. There you go. See how they ran together? And that's cohesion. Super handy. That is what helps. That cohesion and adhesion. Adhesion is when water adheres to something that's not a water molecule, like a solid. So let's try this penny trick. So maybe you've done this when you were younger. Make it rain. Let me see if I can do that here. I feel like my phone's gonna fall. I have it very precariously. Okay, there we go. So we would be doing this in class if we were in class, but you take a drop and then you guess how many drops of water from this dropper do you think are going to fit on that penny, right? And so you start dropping it on there. That's 1, 2. I'm not sure if you're actually seeing that very well. 3. So there's 3 so far, but try that at home if you have a dropper. Honestly, I think you'll be surprised at how many drops. So I won't spoil it for you now, but try that and see how many drops of water you can get to just kind of hang out on that, to cohesively hang out on that penny. Adhesion. So it's cohesion between the water molecules on that penny, and there's adhesion between the penny and the water. That's super important because when our liquids are traveling around us, right, like blood is made up of some water. That's what helps the nutrients and just everything get around our bodies with that cohesion and adhesion properties to water. Also, when you're talking about transpiration in plants, so that water travels up inside the plant, and it's against the, sometimes I forget the parts of plants like phloem and things like that, but it sticks to, or it adheres to the sides, and so it's adhering to the sides, but because water molecules are there, it's going to attract to the other water molecule, and basically eventually that moisture is going to leave the plant, right, in evaporation. So it's transpiration, evaporation, all those words when you're talking about plants and stuff. So those properties, adhesion, cohesion, super important. Here's another sample. Hold on, I'm down here. This dropped. So let's say that that's my lovely palm. I'm new at this, whatever. Guess we won't be making TikToks anytime soon. So you have your water, right? And I'll pick up here. You know what? We'll do it in this lovely tray I have. So you spill some water. Yikes, I spilled my water. And then you take maybe a paper towel. I have a piece of toilet paper here because I don't have paper towels. I'll show you the kind of towel I have. I don't really buy paper towels. So here, if you soak that up, right? Here I have a bamboo towel, right? I don't buy paper towels. I buy these amazing bamboo towels. I'll show you the product in just a little bit. But, right? And that's absorption, right? It absorbs into this towel. But there's another word you might not know of, and it's called adsorption. A-D instead of A-B. Adsorption. And that's when you're like, oh no, I spilled something. Hold on, let me spill some water. Spilled some water. Yikes. You're like, oh no, I have no paper towels. What the heck? You're like, I have a piece of paper. That'll work. And then you stick that paper on there. You're like trying to soak it up, but it's not really. It's kind of dripping off. So that's adsorption, right? Now eventually it will soak in, and that'll be more like absorption. But adsorption is when you can easily separate those water molecules away from that solid. So when you have a carbon filter, I mean, a charcoal filter, carbon filter, a charcoal filter like in your water pitcher or in your refrigerator filter. One of the things they have you do before you put that in is they have you rinse it through a couple times. But also, if you take that, you can actually kind of shake it, and you know, some of that water will come apart from that blackness, that charcoal. So that's because the charcoal is adsorbing that water, not absorbing. So anyway, that's one of those differences. And then one more thing. No, two more things. So another thing is when we talk about these hydrogen bonds and how important they are, another reason they're important is because, do you ever see one of those bugs like walk across water? And you're like, oh my gosh, how does it do that? That's because the water molecules are being pushed a little bit, but because of those hydrogen bonds, the water molecules are still staying together, and the hydrogen bonds are strong enough so the bug can crawl across that water and not sink through. Now, if we tried to do that, right, those hydrogen bonds are going to break. Okay, so let's say you have this paper clip, and the hydrogen bonds, boom, you know, broke right through. But you can actually get this paperclip to float, and that's something we would do in class as well. So if you want to try that, try it. Send me a picture if you did it. I'll give you 1 extra credit point. I mean, just for doing all this fun stuff. I'm not going to show you how to do it, but if you want to try to float this paperclip on water, it'll float. Right? You may or may not have to do something to it, but see if you can get it to float, and then send me a picture of that. I can do it really super fast. I usually totally impress everybody in class. They're like, whoa, how'd you do that? And I'm like, I'm a teacher, yo. So yeah, try that. But that's that idea of like, you know, sometimes those bonds are very strong. Hydrogen bonds, if there's a lot of them, and sometimes they're very weak, like I told you in the other video about how DNA has to come apart. So DNA is held together by, the two strands are held together by hydrogen bonds, but when needed, they can come apart so DNA can replicate. So yeah, hydrogen bonds, super cool. Yeah, this was the last thing. pH. So in my younger years, I never really understood pH. I'm like, oh, what's pH? I don't get it. So pH is really the measurement of how many free ions there are. So we're looking at either hydrogen cations, right? Those are the positive ions, or we're taking a look at hydroxide ions, and we're looking at anions. Those are negative anions. So it's literally like the measurement of free ions in the water. So like pure water, it will have an even amount of ions, of positive and negative ions. So that's pure water, and that's at 7. So here, I know there's so many, I'm dropping things, so many better pictures out there, but this is the one in the book. And there's a different one in the PowerPoint if you take a look at that, but just because we're here now, right? So in the middle, that would be that pure water. And as the numbers go down, right, so your numbers get lower, those are your more acidic things, and then your more basic things. So more free hydroxide ions, less hydrogen ions when you are talking about basic, and then it's the opposite, right? So there's more hydrogen ions and less hydroxide ions when you're going down the scale in acidity. So, you know, granted, this goes from 0 to 14, but what you have to know, in between each one is a 10-point jump, actually. So it kind of goes by 10. Because you know that something like, you know, you go from lemon juice to stomach acid in about a 1.5 points, but you know that stomach acid is way more acidic than lemon juice. Yeah, and stomach acid is acidic for a reason. It's good to break things down. It kills a lot of bacteria for us. It's here for stomach acid. And what do you do when you have acid reflux? What do? You take a Tums, right? Or some kind of base, some kind of basic thing. Maybe you drink a little milk, but that's not way high up there. So, well, milk and magnesia. So yeah, now you can't overdo it on the Tums or milk of magnesia, because your body will then react with, remember, homeostasis, trying to balance things out. So if you put too much bass in your, it sounds like I'm talking about music. There's never enough bass. If you put too much, a basic, like a ton of Tums or milk of magnesia to try to balance out your acid feeling, your body actually might create more acid because it's trying to balance things out. So keep it real with those Tums. Don't go crazy. Yeah, so water, pretty cool. H2O. That's it.